Good evening and welcome to Solving Quadratic Equations. We're going to have a look at three different methods of solving quadratics, and each method has its own strengths and weaknesses. Factorisation, completing the square, and using the quadratic formula are appropriate in different places. Factorisation, though, is definitely the quickest of the three. If you can factorise, you should, putting it in brackets and then quickly pulling out the answers from those brackets. Each quadratic equation has possibly two solutions, one solution, or no solutions at all. Let's have a look at factorising. We're going to have a look at quite a simple quadratic here. This is going to be x squared plus 2x minus 24 equals 0. If you're putting that in brackets, you've got to have two numbers at the end that multiply together to give you the minus 24, but add together to give you the 2. If you were to multiply those brackets, you've got to make sure the minus 24 and the plus 2 would come back. And here 4 and the 6 works nicely. You've got to have one negative. So the minus 6 wouldn't quite work, but plus 6 and minus 4 works perfectly. That means you're solving two miniature equations that equal 0. So either x is going to be 4 or it's going to be minus 6. That's brilliant. The second method we're going to look at, completing the square, is a little bit more complicated. But once you know the way this works, you can quickly rearrange the style of equation and find the answers really quickly. Let's have a look at the same equation this time, but we're going to put it into this particular style. You have something with the x in brackets all squared plus an extra number, and what you have to do is take the quadratic you're given and chop the number in the middle in half, and that goes in the brackets with the x. That whole thing is squared. The 24 stays there, but you have to take away that number squared from the brackets. Then you simplify, then you move that number over. This time you get a 25, and you can square root that really easily. And when you square root, you get either plus or minus 5, and then you can subtract away 1, you get your two different answers. The same answers we had last time. So that's completing the square. That takes a little bit longer than factorisation, but it would work even if you can't factorise. Then there's the classic quadratic formula. The quadratic formula is x is going to be equal to minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. But those a's, b's and c's, they come from somewhere. They come from the general form of a quadratic equation. The a is in front of the x squared, the b is in front of the x, and the c is the constant term at the end there. You put those numbers into the right place and simplify, and eventually you'll get back the right answer. In this case we have the a is 1, the b is 2, and the c is minus 24. You put them in the right place, and in this case we're going to have a relatively nice number coming out underneath the square root. There's a square root of 100, that's perfect. So we end up with the same solutions we had last time. Now, the completing the square and using the quadratic formula, they both take a little bit of time, but again, this would work even if you can't factorise. Let's have another look at a different quadratic, another simple one, but if you look at the differences between these three methods, you can see that factorisation is going to be a lot quicker. That is if you can factorise it. This one's got a minus 10 at the end and a minus 3 in the middle. You've got to think of two numbers that would multiply together to give you minus 10 and add together to give you minus 3. And I think you've got quite a few options because of the minuses, but it could be a 1 and a 10 or a 2 and a 5, and you could have a minus of one of them and the plus of the other. Let's see, this is going to be, I think a 2 and a 5 would work nicely. And we'd have to have a minus 5. If we're going to get a minus 3x, that's great. So the answers come straight out with the opposite signs. Completing the square, though, for this particular example, it's not as nice as the other one, because we've got an odd number in the middle. That 3, when you divide it by 2, you end up with a 1.5 inside the brackets, but it still works. You have to subtract 1.5 away squared, and that's going to give us 49 over 4 here. Going over there, square root, both sides, you get 7 over 2. Plus or minus, of course, because you square rooted, and then you can add the 3 over 2 to both sides, and you get the same numbers back. So that looks as though it's almost twice as much writing, twice as much effort in order to get the same answers back. The quadratic formula, we've got the 1, the minus 3 and the minus 10, that goes into the formula, simplify the bits underneath the square root, divide by 2a, and then this again should be a nice number underneath the square root, 49, perfect. So 3 plus or minus 7, and the whole thing divided by 2, we get the 5 or the 2 coming back again. Okay, of course minus 2 and the plus 5.